So, hello everybody. This is me again, Andre, and I'm going to continue one of my other videos, which is about calculus. Okay, limits, derivatives, integrals. We're going to do that again because my OBS studio back then it was absolute garbage. It didn't record any of the strokes that I was making in Microsoft Whiteboard, so I just had to discard the video entirely, even though I was literally doing that for like an hour and a half. So I'm just going to do it again. So this is going to be the part two of it. Okay. Sorry if I started out very aggressive with this. So let's just start with limits. Okay. So limit. What is limit of x as it approaches 3? Okay. So we have here the function x squared minus 9 divided by x minus 3. Okay, so we're trying to find the limit of this. So first we have to substitute the unknown variables with 3. Okay, so let's see if our answer will be a whole number, a real number. Okay, hopefully it will. So 3 squared, basically just 9 minus 9. Okay, so it's gonna be hold on. So 3 minus 3 is going to be 0 of 0. So we're going to have to factor. We're going to have to factor 9, I believe. Okay, so we're going to factor 9 because of what we call the. Hold on. Here it's like this. Okay, so we're going to have to factor 9. I think it was because of a rule called product. Hold on. Yeah, I don't really know what the rule is, but I know that you have to factor this. So in order to get minus 9, what adds to what? Well, no. What multiplies to negative 9 is basically just I believe this. Hold on. This basically just a study session. It's not really me teaching anything, but I'm going to be teaching some stuff along the way. So let's just see the example here. I know this is already included an example. So x minus 3, we just have to find the values that multiply to negative 9, I believe. Negative 9, hold on. Yes. That multiplies to negative 9. It's going to be negative 3, and the factor form would be x minus 3 times x minus plus 9. Plus 3. Okay. So we just have to cancel the similar terms. Then we're going to be left with x plus 3. Okay. So now that we're left with this simplified version of it, the factor version of this equation, we're just of the function, we're just going to have to substitute the variables again, and just like what we did earlier. Okay, just like what we did earlier, we're just going to substitute the new variable and 3. So 3 plus 3 is 6. So the limit of x as it approaches 3 is 6. Okay, so let's start with the second problem. But first I'm going to erase this, okay? It's just there's not a lot of space in this whiteboard. So let's start with limit as x approaches 2. I already know the answer is going to be probably some 0 over 0, but hopefully it's not, okay? So we're just going to substitute the unknown variables with 2. Minus 6, x minus 2. Okay, so 2 squared is 4, okay, plus 2 minus 6. So we just have to, okay. So 4 plus 2 is 6. Yeah, I knew it. It's going to be a 0. 4 plus 2 is 6, minus 6 is 0. Then it's going to be 3. Wait. Hold on. Yeah. 2 minus 2 minus 2 is 0. So we're going to have to factor this again. So This is going to be a little bit more difficult, but it's going to be 6, okay? What what multiplies to negative 6, okay? What values multiply to negative 6 going to be? I believe it's going to be, hold on, x positive 3. It's probably going to be like that, okay? So now we have to add x minus 2 here. So we have x minus 2 again. So we have x plus 3 again. Now we just have to substitute the known variable with 2. So 2 plus 3 is equal to 5. And then the limit of x as approaches 2 is going to be 5, okay? So let's head on to the next question. Let me just check if my answers are correct, because I already have the answer sheet here prepared over here just to for the hold on. I believe it's here. Yes, I'm using ChatGPT. I don't care. Okay, this is a study session, not a lecture. Okay, so I'm going to be right on the first 2 questions. That's going to be 6 and 5. Okay, so let's start with the third question. What is the limit of x as it approaches limit of x as it approaches negative 1? Okay, so this is going to be, I believe it's going to be a special case, but I'm still going to do the standard procedure of this. So negative 1. Okay. Negative 1. Negative 1 cube plus 1, and then x plus 1. Okay. So we're just going to try, and then I believe negative 1 cube is going to be positive 1. So positive 1 plus 1, x plus 1. Okay. So we're just going to add negative 1 here as well. Negative 1 plus 1. Oh, it's going to be 0. 0 over here. Okay. Plus 1. Oh, hold on. 1 plus 1. It's going to be 2. Let me just check if I'm right in my assumption. Okay. What? So I'm wrong. Okay. I see, because you have to yeah. Okay. So it's negative 1. It's actually negative 1. I'm sorry about that. So it's going to be 0. I just forgot that you actually have to yeah, I just forgot the signs. Okay. So there's going to be a 0 over 0. Okay. So we just have to factor again. So what multiplies to 1? Okay. What multiplies to 1? Well, we're just going to have 1. So not sure if I'm doing this right. I think I am. I'm doing something wrong. I know I'm doing something wrong. Let me just check the answer sheet. Okay. So the third question is going to be 3. What? How is it 3? Okay. Let me just do this. Let me just do this again. We have negative 1. Okay. And negative 1 plus 1. It's going to be 0. Yeah, negative 1 plus 1 is going to be 0 again. Try to find the Let me just ask a question to ChatGPT. Sum of cubes, so factor it. This was just the only thing that really trips me up, like sum of cubes. Hold on, let me just sum of cubes. Okay. Okay, so if I'm getting this right, I think. Hold on. What? But the cube is 3, right? So how did it come to this? How did it come to this? X plus 1. Did they separate? Did they separate the other x that makes up x cubed? So that's why there is an x plus 1. Is that why? I was right on x plus 1 being on both sides, but I didn't anticipate that there's going to be x squared as well on the right side, the factors. Let me just search up what a sum of cubes is. You learn something every day. So you have sum of cubes of natural numbers. Oh. Ah. I think it's just going to be like that. I guess we'll just do that then. Okay, let's just do the sum of cubes that it's talking about. It's gonna be x. Oh, hold on. So we have x plus 1, and we also have x squared minus. But why did it turn to x squared? Why? Why did it turn to x squared? Then minus, nonetheless. I think it's because you have to have like a negative and a positive on the factors. I guess that's why. Don't really comprehend what the thought process with that was, but I think I'll just accept it for now. In order for us not to overcomplicate things, we're just going to accept that. Okay. The sum of cubes. This is the first time I'm hearing this rule limitations. So we're just going to substitute everything. But first we have to cancel out the common factors. So we have the common factors here. Just gonna be just this. Okay. We just have to substitute x squared. Oh, let me just substitute right away. We have one over here. Okay, 2 and minus. Hold on. 1 plus 1. Okay. So you have 0. So it's gonna be 1. It's gonna be 1 plus 1. It's gonna be 1/2. It's gonna be 1/2. What? you talking about? Okay, okay. I get it now. I get it now. Because there's an also we're completely disregarding the extra negative sign that is outside of this. So we just going to have to distribute that negative sign, and this will turn to a positive one. This will be positive one as well, and positive one, positive one, positive one. So we have what is it? Okay, so we have negative one plus one. It's gonna be zero. So uh, it's gonna be three divided by zero. It's gonna be zero. Three. Okay, so that's gonna be the final answer for that's the third limitation. This is the first time I'm hearing what a sum of cubes is. By the way, uh, this is so unprecedented. It's unexpected. So we're going to the next question now. The fourth question. What is the limit of x that it approaches four? It's going to. Oh, this has a cube now. This has a square root now. I hope this is. I hope this won't equate to 0/0, cause then. Oof, 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 oof. We're gonna learn something new in calculus. I'm going to be very honest with you. One thing I hate about calculus is that there's always something new. Like, if you happen to not understand something, there's always an explanation for that. Like, and the fact is, you don't understand a lot of this. You probably can't understand a lot of this without any foundation at all. Okay, it's it's like it like rewrites your basic understanding of math in general. Like, it doesn't follow most of the conventions that you see in algebra. Like, for this example, you have to do so many stuff that is completely outside of what you learned. Okay, so completely outside of what you previously learned in algebra. Okay, so it's gonna be four. Okay, so we have four. 4 minus 2 and 4 minus 4 is gonna be 0 over here. And then we're gonna have the square root of 2 minus 2 is gonna. Oh my gosh. Oh my god. It was just gonna factor it again. Oh my goodness. Gonna factor it again. Alright. Let's just factor it. So how do you factor this? I'm very confused. So you have negative 2 over here. How do you get negative 2? Okay. So what equates to negative 2? Okay. So I'm gonna say it's x plus. Hold on. Hold on. X plus 1, then x. Negative 2. So we're gonna have x plus 4 here. There are no common factors. So how are we going to approach this? How are we going to approach this? Can cancel out the common factors because there is no common factor over here. So how am I supposed to approach the this search? I'm gonna go to my trusty assistant, trusted assistant, and am I supposed to solve the fourth question? I even spelled question. Get zeros in determinant. To rationalize the numerator, we need to have. Oh my goodness, a difference of squares. Okay, I don't know what that is. I don't know how that related to this specific example, because there's a square root. Ah, it's probably because of it's probably because um so you have a square root, right, and then a square root of x and a negative 2 over here. The reason why it's probably a different squares because there is a square root over here. So you're trying to find the root of that number, and this it's probably going to be 4 as well. No, it's not going to be 4. Just you're trying to find the root of that number, so that inherently means that um, both of the numbers have a which is begging the question, just difference of squares. So let's just go back to what my best friend ChatGPT is yapping about. Okay, so multiply the numerator and denominator by the conjugate of the numerator. Ah, so you have to. Oh my God! What? 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 What are you talking about? What are you talking about, dog? Okay, so we have uh, uh, different squares. How does the difference of squares work? Difference of squares method. I've already searched this up. That's actually kind of unprecedented. So we have a plus b, a minus b is equal to the product of the sum in a and b. All right, let's just do it. Let's just try it. Okay, I'm not going to rely on ChatGPT. Okay, or Google for that matter. Let's just try it for ourselves and let's see what happens. Okay. Huh, oh, oh. Oh, so how does this work? We have an x minus 4 here. How do we get? Oh my goodness! Actually, I skipped another point. Just have to keep trying. Multiply the numerator and the denominator by the conjugate of the numerator. What is a conjugate? Let me in math. Changing the sign between two terms in a binomial. Oh. How does this work? This is actually really uncomfortable, if I'm gonna be honest with you. Oh, I see. Okay. Okay. I get what he means now. I get what it means now. Okay. I get what it means now. Okay. I see. So when it comes to difference of squares in limitations, you basically just have to multiply the whole equation with the conjugate of the numerator, which is basically just the opposite of the operation that is in the numerator, and just put that in both the numerator and the denominator, so as to multiply it with the original equation. So it's just going to be like this. Okay, so we're just going to copy this, and then times it with the conjugates. So we have x plus 2 over here. Okay, we have x plus 2 and x plus 2 over here as well. Okay. So how we're going to do this is we're going to times this. I'm just going to times this. Okay. So what happens? What happens afterwards? What happens afterwards? Okay, okay, okay. I think I see where it's going now. Probably, probably not. I don't know. This is a little bit hard. Let me just let me just ask ChatGPT to simplify your explanation. Because I already know ChatGPT is always on some BS, bro. I'm not even trying to be mean to ChatGPT, okay? I already know there is some hidden assumptions there. Like there are hidden assumptions. Like ChatGPT just basically skips steps and thinks you know the steps in between, so he just doesn't try to explain those steps. So we have here, okay, the conjugate of x minus square root of x minus 2 is x square root of x plus 2. Top becomes x. Okay, I understand this part, but why do you have the x squared as well, the denominator? Why do you have the x squared in the denominator? What does that have to anything to do with anything? Cancel the x minus 4. What? If you cancel it, then it's going to be 0. Why is it 1? Why is it 1? It says here the top becomes x minus 2 times x plus 2. You get x minus 4. Okay? So now you have that x minus 4 on top on the numerator. And then it says to cancel the x minus 4. You're going to cancel both of them. Then the numerator should be 0. Why is it 1? Why is it 1? What? Look. Oh my god. Okay, let me just search this. Okay, so why did the denominator and y cancel x and both numbers by the denominator? Why did x plus 2 end up in the denominator? We started with that. I see. I see. canceling x. This 46 is dividing both the top and bottom by x minus 4 is equals to 1. Oh, okay, I understand it now. 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 Okay. So it's gonna be 1. Understand it now. Yes, I understand it now. So we just have to multiply that, okay? So it's gonna be like this. Let me just erase this. Okay, so we're just going to get the difference of squares method is basically just multiplying multiplying these to the conjugate of the numerator. Okay, so let's just start. Let's first draw out the fraction sign over here. So we have x minus 2 times square root of x minus 2 times square root of x plus 1. Square root of x plus 1. And then we have square, I believe it's x minus 4 times square root of x plus, oh, why did I write 1? It's actually, hold on. It's actually positive 2. Positive 2 over here. It's positive 2 right here. Okay. Why did I write 1? What a klutz. Okay, so now we're just trying to... Okay, just multiply this thing. So 2 times, negative 2 times 2 is going to be negative 4. So we have square root of x and negative 4. Then just have to cancel out the... hold on. Oh. Let me see if that's correct. Let me just see if that's correct, okay? Okay, so why did it become x? I think it's because you multiplied both of them, both of the squares, and that becomes a whole x, I believe. But I'm not really sure about that. So it's going to remove that. I think that's my hypothesis on this, why it become x, just an x after we multiplied it. It's probably correct. I don't know, but let's not delve too deep into that. Okay, so let's just go x minus 4. Then we have square root of x plus 2, and then we remove the common factors, and we're just left with x squared plus 2. Then we're just gonna have 1 x squared plus 2. Okay. So since we have now we already have that. Okay. We're just going to substitute the unknown variable with what is stated in the limit. So that is 4 square root of 4 plus 2. The numerator will be 1. So square root of 4 is 2. So 2 plus 2 is 4. So we're going to get 1/4. As x approaches 4, we're getting 1/4. Okay, we're getting a quarter. Okay, so that's the final answer for fourth limitation. Okay, so let's go to the fifth number now for the last example of the limitations. Mind you, we're not even halfway through the questions yet, and this is only 5 questions. Okay, these are only 5 questions. I'm begging you, please. These are only 5 questions. We have 10 more questions left, and these are different topics. Goodness gracious. Oh my God. Let me just Okay, let's just do it. Okay. So we have the limit as x approaches 1. We have x squared. Let's try 1. Of course, we have 0. Yep. Yep. So we have a difference of squares. I think this is cube rule. Cube sum of cube. Yeah, sum of cube. Okay, this is the sum of cubes rule. Let's get another glimpse on what the sum of cube rule is. Cheers to you for giving me a chance. I'll be your angel, guardian man. Cheers to you. Let's have some examples. So examples of the sum of cubes rule. Okay, I already had an example earlier, but I already forgot because I can't really explain what the sum of cubes is. So let's just wait. Sum and difference. Okay. Let's go back to our trusted advisor, the organic chemistry tutor.
In this video, we're going to focus on factoring sums and
By the way, this is all credits to the organic chemistry tutor. You guys can check his channel out. So the video I'm watching right now is factoring sums and differences of perfect cubes. Okay, all credits to him. Please do not copyright me.
difference of cubes. So let's say if we want to factor the expression x cubed plus 8. Now, there is an equation that you want to use. And here it is.
Okay.
A to the third plus b to the third. This is equal to a plus b times a squared minus ab plus b squared. So you need to realize that a to the third is the same as x cubed in this problem. Therefore, if you take the cube root of both sides, a is equal to x. Now, b to the third is equal to b. And the cube root of a is 2, so b is equal to 2. And now we just gotta plug in everything into the formula. So just keep in mind, a is x, b is 2. So a plus b, that's gonna be x plus 2. A squared is x squared. A times b, or x times 2, that's 2x. And b squared is 2 squared. 2 times 2 is 4.
Okay, so
that's how you can factor.
So we're just going to have this long formula in order to find out sum of differences. No. Sums and differences. The sums and differences of cube. The sum of cubes rule. I'll be right back. I'm just going to throw some. So we're just going to follow this formula. Okay, we're back. Let's just do this. Let's copy this formula right here. I'm just going to screenshot it so you don't have to copy it letter by letter, number by number. Thankfully, this will be one of the last. Okay. I believe this will be here. Yes. Okay, so this is the sum of cubes rule. All we need to do is substitute, okay? So we have x3, here as a. Then a b cube. B cube is going to be -1. Yeah, it's going to be -1. What is the b cube? What is the cube of -1? We know that's +1. Yes, it's +1. So we just have to add this. We just have to. Okay. Okay. Let me see if I'm doing this right. Oh, yes, 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 yes. I actually forgot. So you're supposed to get the cube of the x, so we got x instead of x cubed. Yeah, +1 over here. +1. Okay, so now we have to get x plus 1, then x squared minus x. X times 1 is just x, okay? It's just x. So we have x plus b squared is going to be 1 squared, so basically just 1. 1 squared. It's basically just 1. Cheers to you. So I think we're going to see that now.
Sure. This particular expression. But let's go ahead and try another example. Let's say if we want to factor the as x times 25. So instead of writing a plus b, this and then it's multiplied by a squared or x squared minus a times b or 5 times. And so that's how you can factor.
Let me just go back here and see how they solve this. How to solve this. I'll just ask ChatGPT how it solves this, and I'll just see if my approach to this is correct. Why is it a plus? Why is it a plus of the second x of the second parentheses? I think I think it probably depends on the value of the of a and b. I think. Now your limit becomes this. Yes, I'm correct. I'm correct. I'm correct. Okay. My approach for this problem was correct. So we just have to copy the denominator, then we cancel out everything that is yeah, just cancel out the denominator. Let me just check this out again. Why is it -1 over here? Why is it -1 instead of +1? This is like that. It's actually negative 1 here. Why is it not positive 1 if we're trying to ask for... What? First of all, okay, that's a contradiction to what I said earlier. Because if it's a negative 1, then this should be a negative 1 as well. It should be a negative x as well. But why is it negative 1? Why? Why? The formula says right there. I think it's a problem with how ChatGPT probably approaches this. It's either with ChatGPT or with the organic chemistry tutor. But either way, you know, can't really argue with them about it. I'm just going to follow this. I guess I'm just going to cancel the x minus 1. Then we're going to be left with this. We're going to be left with x squared plus x plus 1 squared. So we're just going to substitute now. So we got 1 squared plus 1 plus 1. So it's basically 3. It's a square. Yeah. Yeah, it's 3. It's 3, it's 3, it's 3. That was such a maze, bro. Like that was so confusing. Like the formulas that they were using were entirely different from each other. I don't know. I don't really know how that worked, but the only problem that I encountered was the difference in the signs. Okay, the difference in the signs. But otherwise, the approach that I tried was correct. Was intuitively correct. So that's going to be the answer for fifth limitation. Now we're going to proceed to derivatives. Okay, I'm going to proceed with derivatives. Okay. So let's go with the sixth question. We have derivatives right here. I'm actually quite kind of good at derivatives. I'm just kind of good at it, you know. Just kind of. I didn't say I'm just saying I'm really good, you know. It's kind of. So I think I'm gonna have a much easier time with this because I actually do a lot of this. I actually did a lot of this when I was my first year of college. I was scribbling down a lot of derivative problems and solving them in the library. So what we call this is the constant multiple rule. We're just going to use the constant multiple rule in here. So basically, you just have to use the power rule in derivatives, trying to differentiate this problem. So let's start with 6. What is the derivative of 5x to the power 4 minus 3x squared plus 7x minus 9? Let's say. So we have a constant over here. First order of business. What's the 5 times? We have 5 times 4x cubed. Then hold on. Let me just 4x cubed minus 3 3 times. I'm just going to use a little dot here for the multiplication because there's a lot of multiplication happening. Okay, just not make it more confusing than it already is. Okay, so yeah, just going to use the power rule here. 3 times 2x. Then we have plus 7 because derivative of x is what's the derivative of x? We have one. We have derivative of x1, x1 minus 1 is 0. So it's going to be x to the power of 0. What is x to the power of 0? I believe it's 0, right? How it's either 0 or 1. X to the power of 0. Okay, okay. It's to the power. It's 1. X to the power of 0 is 1. So it's gonna be. I knew it's gonna be just 7 here, and minus 9. Okay. I'll be right back. Actually, I'm just gonna take a quick break, quick bathroom break. All right, let's continue over here. So now we have to multiply these in parentheses. We have 5 times 4, 20x3 minus yes, 3 times 2 is 6x, and 3 times 2 is 6x plus 7 minus 9. We combine the like terms, it's going to be 20x cubed minus 6x minus 2. That's going to be the final answer. I believe that's going to be the final answer. Let me just check the answer sheet here to confirm. I have so many questions over here. Okay, so what? Hold on, buddy. Hold on. Oh, it's a 7x. Oh my god. 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 So I did have a little bit of blunder. I had a little bit of a blunder here. I differentiated the x from 7x when it's actually supposed to be just left there. Okay, so let's just leave the x here. So we have 20x cubed minus 6x plus 7x minus 9 minus 9. I think that's going to be the final answer. Yeah. X minus 6x. Hold on. Seven. But why? Why was it like that? 6x plus 7 minus 9. Okay, so we're just going to disregard. Just going to disregard 9. Negative 9. I believe so. Okay, so we're going to disregard negative 9 because it's a constant, so that just means it's 0. Then I was actually right the first time about what happens to x here. Okay, so what happens to x is differentiated as well. Differentiated as well. So the x is just going to be 1 and 7 times 1. You get the idea. You get the idea. So that's going to be the final answer for 6. Now let's move on to a different question. Hold on. Let me just move on to a different question right here. Let's move on to question 7. Or problem number 7. This is the derivative of 4 over x squared plus 6 x cubed. So we have to differentiate first. Okay. Let's just differentiate first. 2x4 plus 6. It's gonna be 3, 2, 3 times 6 times 3. It's gonna be 18x2. I believe that's the question. I believe that is. Okay. Okay, so I think that's the final answer. I think that's the final answer. Oh, goodness. Why did it turn? Why did it turn to -8? What the hell? Oh, because you have to. I forgot something really crucial right now. So you have to multiply is 2, okay? You have to multiply is 2, so it's -8 plus 2x. Plus 6x. Hold on. No, 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 no. It's 18x squared. Yeah. Okay, so that's the final answer. So let's just move on to the next problem. Problem number 8. Derivative of, oh my god, we got another x, square root of x. Alright, fine. We'll just do that, I guess. Let me just check the rules for derivatives. Let's see if I'm not missing anything. See if I'm missing anything. Missing anything. Alright. So number 8. Number 8 we have square root of x. Yeah, the square root of x. You just have to find the derivative of 5x minus 1. X minus 1, just have to add minus 1 over here. Minus 1 is going to be minus x, negative x to the power of -2 times positive 5. Is that okay? So it's gonna be -5x to the power of -2. Then we'll have the x over here plus that. Let me just see if my answer is correct. And as always, my answer is not correct. Alright. Fine. Let's try to get an explanation from my good old buddy, ChatGPT. How did you solve problem 8? Alright. You write the square root. Okay? Isha, let's just read this. Question 8 is a derivative of square root of x plus 5x to the power of -1. So you have to change the square root of x to exponent form. That's going to equal to x to the power of 1/2. Then the function becomes x to the power of to the power of 1 half plus 5x and negative 1. Use the power rule. Huh? The power rule. I will be there for the love celebration. We can go there anytime, any moment. Yeah. So, excuse me. So basically just the power rule as usual. But why? Why do you have to change the negative exponents back to fractions? Okay, okay, okay. So anything that has a negative exponent, okay, any variable that has a negative exponent is always going to be written as 1 over x, and any variable that is square root is going to be written as x to the power of 1 half. Okay, so let's just remember that, and then we'll try to solve number 8. Okay. I gotta say, man, I'm gotta be very honest right now. ChatGPT is solving this question more than me. Man, if I didn't have ChatGPT, bro, I don't know how to answer this. Like the textbooks that you see, they're very advanced, so you can't really understand all the jargon that they use. It's more or less when you read a math textbook, it's more or less just testing your English more than it is testing your reasoning. Okay, and I think a lot of students can relate to that, especially when it comes to exams. The questions are harder. The way it is questioned is the first thing you solve first. Okay, let's find the derivative. So we have to do this x 1 half plus 5. Then we have to use the power rule on this. So we have okay, so we have negative 1x over here. Um, the negative 2. Negative 2 over here, so let's times that. 5 times negative x. It's going to be negative 5x. Well, negative 2 is going to be, I believe it's going to be 5 plus 0 as well. So it's just x 1 half. So the answer is going to be x 1 half plus let's rewrite this back. You rewrite this. We're gonna have x negative 2. I think that's the answer. Oh god. So we also encountered a problem here. We actually don't add it for instance. We don't add it. Okay. We basically just have 2. Why is it 2? Oh, because 1 is. Oh my god. Then we have the square root of x minus 5. Then, uh, it's x squared. How? What? Okay, okay. Because 1 over here is 5, and then x is going to be x squared. It's going to be x squared as well here. I guess that makes sense. It's going to be the final answer. Okay. So now let's solve for the number 9. Solve for number 9. Okay. So we have 7x to the power of 5 minus 2x plus 8. Okay. Okay, this is going to be a fairly easy one because there's no special cases unlike number 10 right here. So let's just write that. Let's just finish this. Excuse me. Okay, so this we have 7 times 5 is equal to 35. 35x4. Let me just. Yeah, 35x4 minus 2. I think that's the correct answer. Chef number 5. Yeah, it's the correct answer. That's so easy, bro. That was so easy. Thank God that was easy. Woo. Okay, now let's go back. Now let's go to the next question. It's going to be the last question for derivatives. Then we're gonna head over to integrals after this. Okay, so let's start with the 10th question. So I don't really know how I'm supposed to get the integrals for this. I mean, how I'm supposed to differentiate this problem. But I already know that it's gonna be 8x. What's 4? Yeah, I believe it is. Oh, no, 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 no. It's gonna be 4x. Okay, 4x. That's 4. The only problem is I don't know how to solve this 3 over x. How do I differentiate? Let me just find an example on Google. I don't want to rely on ChatGPT that much in solving this. Differentiate fractions with x on the bottom. Fraction is a concept on the top. You can simplify the problem by moving x to the numerator and changing the exponent to a negative. Okay, so we just move stuff around. So we have 3 over x here. We're just going to move x and then move x to the numerator and then differentiate and then put it back to the denominator, and then to make it positive you have to remove the oh my god. And the negative sign for a whole fraction, you're gonna have to differentiate first of this. Okay, so we're just going to okay, let's go back. Let's go back to x. Hmm. So we're going to move that back. Okay. Move it here. We're going to move it here. We're going to differentiate that. Then that will turn into, I believe it's -1. Yes, -1. It's definitely -1 because the exponent because the rule said that you have to make the exponent negative if you're gonna put the variable on top of the denominator. So it's gonna have -1 over here. So -1. We're going to use the power rule to differentiate it now. So we're gonna have -1 minus 1 is gonna be -2. So we have x. We have to multiply it now. We have to multiply 3x and negative x minus 2. So we're gonna have 3. We're gonna have negative 3x. Okay, we're gonna have negative 3x, and I believe we're gonna put the exponent back to here. So let's find the answer to this. Goodness gracious. So why is it -3 instead of -3x? Why? Why did that happen? Hmm. Why did that happen? Oh, so it's because you moved the x back. You moved the x back to the denominator. That's why it's only -3, not -3x. Okay, I believe in Steve. I believe in Steve. Oh yeah, in Steve. Okay, we got the answer. That's the final answer. Okay, so we're done with derivatives now. We have gone through an excruciating 10 questions. Bro, can you imagine that? I've been doing this for how much? An hour and 14 minutes for 10 questions. That's crazy. Like, that is crazy to me. No, let's go with integrals. Now I don't have any much background knowledge on integrals because, as I remember, this is probably one of the most difficult of the two. Okay, there are a lot of cases in integrals. There are a lot of special cases in integrals that you have to consider when you're solving for them. It's basically just the antiderivative, but it's more like a antichrist. I'm sorry about that. That was very okay. Okay, that's just a joke. It's just a joke. Okay. Okay. Let's start with first question for integrals. Let me just refresh my memory on how to solve for integrals right here, because I haven't really studied integrals and integrating that much, you know. So let me just go to ChatGPT again and find this. Okay, so we have integrals. Integration is the reverse of differentiation. So we have, let's say you have uh, an unknown variable with an exponent. You just have to copy the unknown variable, put an exponent on it. Okay, put the exponent, add a 1 to the exponent, then divide it over the exponent plus 1 again, and then you plus a constant. You add a constant, c. Whenever you're integrating for a power rule, it's probably going to be the same as differentiation, you know. We're probably just going to use the power rule, and then you multiply it to whatever the whole number is besides it. I think that's the, oh, yes, yes, I'm correct. That's the whole premise of the constant multiple rule in integrals. Uh, so I'm just going to stop this for a moment. Okay, so let's continue on. So we're just going to let's just copy this, okay? I'm just gonna copy the power rule of integrals because it's very important, you know, for us in order to understand how to solve this. Okay, so let's just put the power rule there. Um. Okay. Okay. So the first question, that is first this, you have x3, yeah, x3 plus 3 plus 1 plus c. Hold on. X3 over 3 plus c. That's going to be times 6. And then we're gonna do this as well. Minus 4. Okay. I hope I'm not getting this wrong. So this is going to be this. I believe this is the final answer. And would be wrong about that. Alright. Alright. Okay. let me just evaluate where I went wrong here. So 2x3 is going to be 2x3 minus 4 divided by 2 is 2x squared plus c. Is that it? Oh, I forgot the 3. Why is it 3x? Okay, so the reason why there's a 3x in the final answer here is because you also have to integrate 3. What do you say? You also have to integrate the 3. Oh, why is there an x on the 3? Let me try it. Let me actually try it. 3 from number 11 times 10 into 3x. Oh, okay, so you always have to when you integrate a constant, you always have to times multiply it with an x. So it's gonna be an x. That's why there's an x, 3x plus c. The constant is gonna be constant c. We have to, and it's gonna be final answer. Okay. So let's evaluate the second integral question. So we have this 5x to the 4th power. So let's integrate that using the power rule. I hate it when there's fractions. It's going to make my job a lot harder, a lot more difficult with these fractions around. So x5 x5 5 times 5. Let's divide this first. It's going to be x5 here. Then plus 2. We have to. I know I'm going to be wrong at some point. I'm just trying to do a little bit of trial and error. See how this works. So let's try and integrate that. You have x4. How do I solve this first? All right, I think I get it. Just rewriting again. Just rewrite everything. Just add to 2x negative 3, and use the power rule on x to x raised to negative cube. So we have to use this. Negative 3 plus 1 over negative 3 plus 1. Negative 2. Here we have x negative 2. Then we're just going to let's see. The answer will be x negative 2. So just have to rewrite that to 1 times x negative 2. 1 over x negative 1 over x. Negative 1 over x squared. And I believe we're just going to times that to 2. Yeah. Times that to 2, that's going to be negative. So we have s5 minus minus 2. 2x power negative 2. Or x5 minus 1 x squared. So that's the probably the final answer. Oh, I forgot the constant. Okay, you always have put a constant at the end, a constant c on the end, whenever you integrate something. So let's move on to the next question. Question 13. All right. So we have yet another square root of x. That is a lot of square root of x's. Let me just. Okay, let's get back. I'm just gonna read a few of the rows here. Yeah, some are different. We have we have difference of square. Does that do anything? Let me just see what the answer is to this. I'm really just trying to learn this. It's 13. Let's start. What? How the hell did that happen? What the? How did you solve 13? Problem 13. Oh, shame. Let me try this. I didn't read the whole thing. I was just reading the sort of overview on how to do this exactly. So we have to first we have to do a power rule. We have to rewrite the squares. So just rewritten as x negative one. Uh, uh-huh, uh-huh. X of x to the power of 1/2 plus. It's gonna be rewritten as x 4x negative 1 to the power of negative 1. And since this thing is a 4x to the power of negative 1, it's basically just 1 over I believe that's 1 over x. Okay, it's going to become 4 ln then x, but otherwise it's going to be a negative here. So let's use the power rule on this. You can't use the power rule on this because it's it's one of these. So let's use the power rule on this. Basically just half x, then 1 over half plus 1. Okay, that's 1 over half plus 1. 1 and 1/2, I believe it's going to be 1 and 1/2. Okay, now you just times it. Just times that. What? Times that 1 and 1/2. 2 and 1/2, I believe. I believe it's 2 and 1/2. Two terms. So, 7%. I'm just gonna skip 13 because it's too difficult. But I guess we'll just do the last do the 14. Okay, do 14 because there are too many stuff that is inhibiting my ability. There's too many variables in here that is inhibiting my ability to really solve this properly. So let's do the number 14. So we have 8x cubed minus 7. So we just have to times this 4. Okay, so 8 divided by 4. It's gonna be like that. Okay, it's gonna be 1 4. It's gonna be 2x4. 2x4 minus 7x plus c. I believe that's the answer for 14. Let me just check the answer sheet. 14, 2x minus 4. 2x to the power 4 minus 7x plus c. I'm correct. I would be correct on that. Okay, now let's go to the last. Let's go to the very last number. I hope I can answer this. I'll try not to look at any of the answer sheets for this one because this is the last question. Okay, it's the very last question for this video. I'm just trying to solve it on my own. So you have to rewrite that. We have to rewrite that. We have 3x plus 9x. I don't think you have to do anything with 9x. Or do you? Let me just see. Let's use the power rule. Let's use the power rule. We have x negative 2 plus 1. Then negative 2 plus 1. We get x negative 1. Then we have to times that by 3. So that's going to be negative 3. Negative 3 and then x. Oh, hold on. It's gonna be negative 3 and then x. Just x. X. I believe that is. Then 9 times the plus 9 plus c. I believe this is the final answer. 9 half. 9 half. Okay, so I'm right on the first thing, but 9 half. How'd that happen? 9 half times x squared plus c. Let me redo this first. Let me redo the x. How'd that happen?
Turning phone off.
Okay, so we just have to use the power rule again on 9x. So x 1 plus 1 1 plus 1 is 9. Okay, then we just have to use that. X squared is gonna be x squared, right? 9 9 over 2 and then x squared. Because that's what it says here. Yeah. So we're just gonna have 3x 9 over 2 x squared plus c. So that's gonna be the answer for 15. Okay. That's gonna be all for today's video. Thank you for watching. If you can, or if you want to, please subscribe to my channel. That'll help a lot. Thank you. I appreciate you, man.